Hi there guys, and welcome to this video on area of sectors. Now, let's have a look at what we mean by a sector. Well, first of all, this picture here is a circle, but all of these are actually called sectors. Now, you should know the area of a circle is equal to pi r squared. If you didn't know that, there's a very catchy song on YouTube, a circle song, that will get it into your head forever. Now, this you should be really happy with. When we move across here to the semicircle, you should be pretty happy. Well, that would just be half of pi r squared because it's half the circle. Now, this looks like a quarter of a circle. We can't actually assume it's a quarter unless we see that right angle sign. But this would be a quarter of pi r squared. All of this I expect you to be incredibly happy with. And for this one, 3/4 pi r squared. Now, we can make it slightly harder. So, what I mean by a sector really is part of a circle, a fraction of a circle, but it's a little bit more than that. It has to have two radii, so this being the center of the whole circle, and here are our radii. So the angle is made between two radii, and this curved surface makes a sector. There is something we're going to be looking to in future lessons, and that's called a segment. So that's between the circumference and a chord, but between the circumference, which we call this an arc length, and two radii is a sector. So a slice of pizza essentially is a sector, a slice of cake. Now, so this one might make you think a little bit more, but this is now a sixth of pi r squared. Now, how did I know that? Because there's 6 of those in a whole turn. This one may be even harder still for you to see, but I've seen it so many times, I recognise there's 5 of those in a whole circle. Now, that's not too bad. But then, when we make it a non-friendly number, what I mean by that is it's not a factor of 360, we have to just think about a good way of doing this. So let's just go back right to that first slide. If we cut a circle in half, we've now got 180 out of 360 degrees. And you can see the connection between there. If we've only got a quarter of a circle, we've actually got 90 over 360, which is the same as a quarter. Here, we've got 60 out of 360, it's the same as a sixth, but it's in our interest to always find the simplest fraction we can use. You know, we do that naturally in life. We simplify everything. You know, you wouldn't go into a shop and ask, if you wanted to go into a shop and ask for 5 Mars bars, you wouldn't say, "Hi, can I have a Mars, please?" Because people would think you're a weirdo, and rightly so. So we simplify things. But this, as a fraction, can't really be simplified. So what we're going to do is go 63 over 360, and that is our fraction. It's not a particularly nice one, but just times it by pi r squared. This one will be 71 over 360 times pi times radius squared. Now, you'll notice I haven't found the area of anything yet, and that's because I haven't told you any radii, but it doesn't matter. I'll do it now. So if that's 6 centimeters, I would just type into my calculator 63 over 360 times by pi times 6 squared. I'll do that for you now. So 63 over 360 times pi times 36. And that is equal to 63 pi over 10. That's in terms of pi, an exact value. Or if you want to write a slightly worse but nonetheless decent answer, it's 19.8 to 3 significant figures. So we need to write a formula. So to find the formula for the area of a sector, it is just theta. That's the symbol we use for an angle. You would have seen it when I did the trig ratios. So theta over 360 times by pi r squared, and that is the area of a sector. That's just what you need to know for this. So let's have a look at some questions, some proper exam questions. So these are typical exam questions. I'm going to show you 4 of them, and then it'll be down to you. So they're going to tell you it's a sector, even if you can't recognize it. They'll probably tell you everything in text and in picture form, like they have here. They The only time they've mentioned 80 is in the picture, and it says very clearly work out the area, and they want it to 2 decimal places. So 80, there is a simplified fraction, but I'm going to say it's 80 over 360 times pi times 7 squared, a fraction of the area. Simple as that. So I'm going to just do 8 divided by 36 because I can see that I can divide both by 10. And then to speed things up, I'm going to times that by 49 pi. Anything I can do to type in a little bit less, then great. So that actually is 98 pi over 9, but they wanted it to 2 decimal places. So that's 34.21 centimeters squared to 2 decimal places. That is also 4 significant figures. Easy peasy. So this is more of a reverse problem. I like these far more. So this time they're telling you the area is 18 pi, and we will need to work out the length of x. So what we know is 45 over 360 times pi times x squared, because that's the radius squared. Well, that gives me 18 pi. So now we have an equation, and all we have to think about is, well, we need to find what x is. So that needs to be the subject. So we need to get rid of all of this, and what we do to one side we do to the other. So the first thing I'm going to do is I'm going to divide both sides by pi. Pi's are gone. Now 45 over 360 is an eighth. So what we actually have is this is, I'll write it like this, so an eighth of x squared equals 18. So you can divide by an eighth, or you can simply times by 8. I was going to write it like this, but I just thought it might confuse some of you. But that, to find an eighth of something, you divide by 8. And I think that's so much nicer to now deal with. You can see you need to times by 8, much easier. So if we times 18 by 8, I'm going to just type that in. I get 144, so I get a nice square number. So at this point I'm pretty happy because I have to square root a square number. They haven't mentioned anything about decimal places, so this is looking good. And to square root that, I'm not going to write plus and minus 12. I'm only going to write the positive value because we're talking about a physical length. We can't have a length of minus 12. And I should put in there centimeters. So this has got a bit of a new terminology for us. We've got this major sector. Now, when you have a circle, I'm just going to draw this pink line on here. I might delete this in a minute. So we have a minor circle, a minor sector, and a major sector. Basically, small and big. And they want us to work out the area of the major sector. That's very kind of them because they've actually given us the angle that we need. So that's simply going to be, well, I'll write the formula, theta over 360 times pi r squared. So that's, what am I doing? That's 290 over 360 times pi times 3.8 squared. That's pretty simple, isn't it? But I just included that one because they've got this language of majors and minors. So 29 over 36 times pi times 3.8 squared, and I get to 3 significant figures, 36.5 centimeters squared to 3 SF. So this is the last one. It's a reverse problem again, and it's not finding the side, it's finding the angle. And you can see they've used the symbol theta. So that's how a computer draws it. I just like to do it without taking my pen off the paper, something like that, like a little cartoon eye. So, and sneakily written up here, we have the area to be 5 pi. And you often find that they use pi in their answer. It just makes the whole equation easier because you can just cancel them out. If they give you a normal number, then it's far more difficult and tricky to rearrange and looks a bit messy. So let's write the formula. Theta over 360 times pi times the radius, which we know is 10, that's equal to 5 pi. Have an equation. Let's do the same thing as before. Let's divide throughout by pi. That makes it far simpler. So we end up with theta over 360 times by 100 equals 5. Well, I think you'll be happy to say, to make this the subject, the first thing I need to do is divide by 100, because that's the last thing happening to this term here. So theta over 360 equals 500. Now, I've definitely done something wrong here. So let me just have a little look at what I've done. Wow, you can tell it's late. I've just said 5 divided by 100 is 500. So that's 1 over 20. So you can see I now need to times by 360. So if I do that, so times by 360, that's the same as saying, that's 18, isn't it? It's the same as saying 360 divided by 20, which is the same as 36 divided by 2. So we have 18 degrees. So I've shown you two reverse ones. Just write the formula, cancel everything out, don't be a plonker like me. And otherwise, they're very straightforward. Okay, enjoy.